Good morning, students. Myself, Nithya, Assistant Professor of AI&DS, VSB College of Engineering Technical Campus, Coimbatore. Today, we are going to take Unit 1 Python Programming. So, what are the topics we are going to cover in this unit? Our first one, algorithms, pseudocode, flowchart, iteration and recursion, and one program for your reference, that is find minimum in a list. So before we are going to cover those topics, first we are going to learn what are the objectives in Unit 1. Our first objective is understand the fundamentals of computing and computational problems. Second objective, develop algorithms using basic building blocks like statement, control flow, and functions. Once we have learned the algorithms, we are going to represent pseudocode, flowchart, and programming languages. The same, we have learned algorithm, pseudocode, flowchart. We are going to apply the strategies such as iteration and recursion. So, the final objective is solving the illustration problems like finding the minimum inner list, towers of Hanoi. So the next one, what are the features of Python? Python is very easy to learn and easy to read and easy to maintain comparatively other languages because Python is very user-friendly language and Python has broad standard library because Python has bulk of library which is very portable and cross-platform compatible of Unix and Windows. Then Python has support only interactive mode for testing and debugging. Next, we are going to see interpreter and compiler. As I said earlier, Python is an interpreter languages. That is, see here, this is the block diagram for interpreter. That is using interpreter, our source program, that is high-level languages, will be executed and translated into machine languages, which will be executed line by line. So simply I can define interpreter is defined as translates and executes the program line by line. Then what are the features of interpreter? Converts one statement at a time because as I said earlier, Python will be executed line by line and gets output. So next one, stops execution when an error occurs, and easy to debug because it is an interpreted language, so we can easily identify the errors. No separate compilation step. So the examples of interpreter, Python, JavaScript, and Ruby. So the main advantage of interpreter is easy error identification because if is there any error, we can get easily because it is an interpreter that is line by line will be executed. Disadvantages, slower execution compared to compiler because it will be executed line by line statement. Compiler. A compiler translates the entire program at once and it will be converted into the machine languages. See, this is the compiler block diagram. Compiler gets the high-level languages and it will be executed and converts into machine languages. Features, converts the whole program in one step, displays all errors after compilation, faster execution, creates an executable file, and examples of compiler, C, C++, C++ has Turbo C compiler, Java, here Java uses both compiler and interpreter. The main advantages of compiler, faster execution of the program, and the main disadvantages of compiler is errors are shown after compiling the entire program. Once compiled the entire program, then if is there any error, it will be shown given below. Next one, algorithm. As we know, algorithm is step-by-step procedure for the given problem or for the given any case studies. So the main advantages of algorithm, easy to understand, language independent, helps in program development and simplifies debugging. So the disadvantages of algorithms, time consuming for complex problems. If we suppose if we have any complex problem, algorithm takes very much time consuming for implementing the problems. Then second one, difficult to represent the large logic. The importance of algorithm forms the base for programming. By using this algorithm, we can easily implement or we can easily form the programming languages. So the next importance is improves problem solving skills, and third one is helps in writing efficient program. So if we have to write the efficient program, first we have to make the algorithm. By using this algorithm, we can make easily efficient programs. Here I have given three more examples. First one, just we can order food by using Swiggy or Zomato. That is online food ordering application. So just imagine we have app in mobile application. So suppose I have to order any food in Swiggy or Zomato. First I have to open the app. That is start and stop is the default for the algorithms. First start, then I have to open the food app, that is open food delivery app. Then just I have to enter the mobile number, then select restaurant because it shows the nearby restaurants are there. So we have to select the restaurant and choose food items and add items to cart. Then we have to make the payment. Then finally order confirmed. So like this, we have to order the food in the ordering application. I mean online food ordering application. So what are the application area we are using here? Mobile application development and e-commerce. Second example is banking application. There are lot of features are there. Just I have choose fund transfer. How to transfer the fund from one account to another account. So for that I have to write the algorithm. First one, start. Then I have to log in the banking application, whether I have HDFC or KVB or any other application, any other bank. Just I have to, suppose if I have to use HDFC bank, means just I have to download the HDFC banking application. Then I have to log in, then enter the user credentials, what they have asked in that application. Then select fund transfer option. Then enter beneficiary details. Beneficiary details means suppose I have to send the amount to one new user, means before I have to send, I have to add the beneficiary details for the new users. Then once I have created the beneficiary details, I have entered all the details what they have asked in the application. Then enter the amount. Then I have to click confirm transaction. Finally, it shows transaction successful. Then at last, stop. What is the example here? Real-time algorithms shows how computer programs solve day-to-day problems step by step. So what is the application area here? Banking software and cybersecurity. So next we are going to see pseudocode. As I said earlier, pseudocode is an informal way of writing program logic using simple English. That is an informal way of writing program logic. It is not a programming language but helps to design program very easily. Here, I have given one example for pseudocode. Find largest of two numbers. Find largest of two numbers means just we have to get two numbers. That is read A, read B. Then first we are going to start, then read A, read B, because we have to find which one is largest. So just I have to get A and B. Then I have to given the condition. If A greater than B, if A greater than B means just the output print A is largest, else print B is largest. Then finally stop the program. Here start, read, if, print, else, stop. These should be in caps. So next example, that is students pass or fail. So based on the condition we have to measure, based on the marks only we have to measure whether the students has fail or pass. So just start, then read marks. So why we get marks? Because we have to analyze marks only students get pass or fail. So start, read marks. If marks greater than or equal to 50, we have to print pass. Else print fail, that is less than 50. Stop. Then college attendance systems. Same one. In college, faculty need to take the students' attendance. So start and log in faculty. Suppose I'm the faculty of A&DS department, means just I have to enter the marks in my login ID. So login faculty. For each student, then I have to mark attendance. Then finally, once I get all the students' attendance, then I have to save the attendance, then stop. This is the college attendance system. So the next one is hospital patient monitoring system. So here I have to measure two variables, that is heart rate and oxygen level. So as usual, just we are going to start, then read two variables, that is heart rate and oxygen level. Then we have to given the condition, that is if heart rate less than normal or oxygen level less than normal. If heart rate and oxygen level less than normal, just we are going to alert the doctor, that is alert doctor, else continue monitoring. So in this hospital patient monitoring system, we have to get two variables, that is heart rate and oxygen level. Both the variables less than normal rate, just we have to alert the doctor, that is alert doctor, or else continue monitoring. Then at last we have to stop the program. So what is the exam step here? Python pseudocode uses indentation, if else, while, for while, Python. Start and stop are usually only for understanding, not used in real Python. So next one, flowchart. Already we have learned pseudocode and algorithm. Based on the, we have to make the flowchart. A flowchart is defined as diagrammatic representation of an algorithm or visual representation of an algorithm. It shows the step-by-step flow of control using standard symbols. So, what are the advantages of flowchart? Flowcharts are easy to understand because they use diagrams and symbols. So we can easily understand than algorithm and pseudocode. So the next one, they help in clear representation of logic, because already I said flowchart can be represented using diagrammatic or visualization. Then flowcharts make program development easier. They are useful for debugging errors, and flowcharts improve communication between programmers and users. They act as a blueprint before coding. They are language independent. Whether the programmers or users, we have to communicate to programs, means mainly they are focused only flowchart than algorithm and pseudocode. So the advantages of flowchart. Drawing flowchart is time consuming for large problems as the same problem we have seen in algorithms. Then flowcharts become complex and confusing for big programs. The same first one. For the complex problem, it has take time consuming and it has take lot of confusion for making the flowchart. Any change in logic requires redrawing the entire flowchart. Suppose I have to redraw any. Suppose I have to add any customer requirements. Just I have to redraw the entire flowchart. So it takes the time consuming, and they are difficult to modify, not suitable for very complex systems, consumes more space while preparing the documentation. So the exam tip for flowchart, write any 4 advantages and 4 disadvantages for getting full marks if they ask in any 2 marks. Use simple points and clear headings. This is the flowchart for ATM cash withdrawal. Start. Then we have to insert the card into the ATM. Then we have to enter the PIN. If the PIN is valid, process to another what we have to get is, suppose if the PIN is not valid, it shows invalid PIN and stop the process. Suppose the PIN is valid, we have moved to other process. That is what is our main problem here, ATM cash withdrawal. So just we have to enter the amount. If the balance is okay, I mean sufficient balance, we have to get the amount, that is dispense cash. Then finally stop. If the balance is insufficient, to get the stop. So start, then insert card, then we have to enter the PIN. If the PIN is valid, move to another process. If the PIN is invalid, just it shows invalid PIN and stop. If the PIN is valid, just enter the amount. If the amount is sufficient, we get the dispense cash. Otherwise, it shows insufficient balance. This is the process for ATM cash withdrawal. Then one more real-time example, that is student pass or fail. These example already we have seen pseudocode for this example. So here we have to make the flowchart. Start, read marks. If the marks is less than or equal to 50, it shows the fail. Suppose marks greater than or equal to 50, display pass. Then stop. We have two options based on these conditions. Our condition before we have to make the condition, just we have to get the marks. So this is the process for it shows students pass or fail system. Then iteration. Iteration is the process of repeating a set of instructions again and again until a given condition is satisfied. So otherwise iteration is called as looping. So this is iteration is the process of repeating a set of instruction again and again until the given condition is satisfied. Why iteration need? To avoid writing the same code repeatedly. Process of multiple data items to save time and reduce program code length. So what are the types in iteration? For loop, while loop and do while. Do while is not available in Python, but concept has. Real-time program examples for iteration. See here 1, 2, 3, 4 Alice, Bob, Charlie and David. We have 4 users we have mentioned in users. So the 4 users are assigned to users name, and I have to given the condition for user in users. Print F. This is the string shows. Print F double quote hello user, you have a new notification. This is the loop, that is iteration. For loop. Output. See, for user in users, user has 4 Alice, Bob, Charlie and David. So first I have to print first one F hello user, that is Alice, you have a new notification. Then it moves to second one. So what is the second user? Hello Bob, you have a new notification. Third one, hello Charlie, you have a new notification. Likewise fourth one, it shows the fourth one, that is hello David, you have a new notification. So next one, there is no user, it will be exist from the for loop. Next one, checking availability of items in stock. What are the items are there? Items equal to laptop, mouse, keyboard and monitor. What are the stocks will be there? Laptop, computer, keyboard, monitor. Then I have to given the condition using for loop. For item in items. If item in stock, for example laptop is the item. laptop is stock or not available. So if item in stock, print if item is available, else it is out of stock. So here the output, laptop is available. Here where we go to check items. First one, laptop is available. Then move to next one. That is mouse is available. Okay. Then move to same one. Keyboard is available. Then move to again. Go back to items. For last one, monitor is available. So the four items in stock, it will be available. Likewise, it shows the output. So the one program in a list. So find minimum in a list. Numbers equal to 45, 12, 78, 3, 56, 8. Comparatively, other languages using min function, we have to get what is the minimum number in that particular list. That is minimum value equal to min numbers. Finally, print minimum value in the list, that is minimum value. The output is minimum value using loop is 3. So using min function, directly we can get the minimum value of the list, that is number. So in this unit we have learned algorithms and some more examples for algorithm, pseudocode, and we have some pseudocode examples, and flowchart. We have seen 2 or 3 examples for flowchart. So at last, what are the outcomes we have learned in this first unit? Unit 1, understand the fundamentals of computing and identify computational problems. Design algorithms using basic building blocks such as iteration, that is such as statements, control flow and functions. CO3, represent algorithms using pseudocode, flowchart and programming languages. So the fourth one, by learned pseudocode, flowchart and programming languages, we have to apply some solving strategies including iteration and recursion to solve some problems, and CO5, solve illustration problems such as finding minimum in a list, inserting a chord into a list, guessing a number, that is integer number, and towers of Hanoi. Thank you students. I hope this video is very useful for you. I will update the next unit as soon as possible. Thank you.